Alright guys, today it's simple. I'm going to show you two proofs, and I want you guys to be taking these notes just like normal notes. So yesterday we did this, and it turned out to be page 53. Here I would like you to title it Two Proofs with Triangles. So this is going to be 54. And the table of contents, two proofs with triangles. Okay, so let's start with proof number one. Alright, we're going to have a setup like this. And we're going to have y, x, a, b, and p. Alright, we know that these two are the same, and we know that these are parallel. That's what's given. Now what we have to do is we have to prove that AB is congruent to YX. Alright, so what this means, or what we need to do actually, is first show that those triangles are congruent. If those two triangles are congruent, then we can say that the sides have to be congruent. So let me create my t-table here. And here are my statements. The first thing I'm going to do is just write what they gave me. I'm going to say yp is the same as pb. That's given. Also, AB is parallel to YX. And these are both given. Alright, now I have to somehow figure out how would these triangles be the same. Now I'm going to mark up these triangles. I have a side. I also know that these have to be the same. Why? Because of vertical angles. And then also, I know that these have to be the same up here. Now the reason for that is that if I highlight it, I have the Z property going on. Okay, so I have to write down, first of all, this is going to be angle, side, angle. So I'll write angle, side, angle. So angles that are the same. Angle YPX, that would be this angle right here, is congruent to angle APB. The reason for that is they're across the way, so they're vertical. Or, it's actually spelled LE. Alright, the sides, we already did. We already said that YP is congruent to PB. And that was given to us. That means this side is the same as that side. For our last angles, we have angles ABP is congruent to angle PYX. Now that was our Z property. Or the technical name is alternate interior. Now that means, since we have angle, side, angle, we know that these triangles are congruent. They're the same size and shape. So I'm going to say angle YPX is congruent to, and I need to go back here, YPX, to have the same start point, I need to line it up with B, so it'd be BPA. Now the reason I know those are the same triangle is because of ASA. We already did ASA right here. Alright, now the last step. I haven't actually proved what I want to prove here. I proved the triangles are the same, so now I have to say the last step here. If the triangles are same, then AB and YX have to be the same. So I'm going to write that here. AB is congruent to YX. triangles are the same, then their parts are the same. You may remember this is the corresponding parts of congruent figures, CPCF. And that is our first proof. So again, when you do these problems, if you have to show two things are the same, a lot of times, most of the time, you're going to show the two triangles are the same first, and then use CPCF at the very end. So, let's do another one here. Proof number 2. Alright, this is what's given. We will have two circles like this. Not the best circles, but we'll go with it. Alright, and then we are going to have this kind of setup. Now, what they gave us is that that is the same as that. So let me write some letters in here. This is A, B, C, D, and O for the center point right there. Alright, so what we have to prove now, we have to prove that the angle AOB, that's this angle right here, is the same or is congruent to angle COD, which would be this angle here. Now, in order to show that, what we really need to do first is show these triangles are the same. Alright, now normally I'd write down the givens and get my point, but what I know right away is that actually, since I'm given a side here, I don't have any angles. I think I'm going to go with side, side, side. The thing that I'm thinking about is I have these two sides are the same. Also, since we're in the center of a circle, remember that radiuses, radii, are going to be the same size. And I have a couple radiuses here. So let me write side, side, side. Alright, first of all, my first side was the one that was given. Angles side AB and side CD are the same because that was given to us. Now I'm going to highlight two sides here. BO and OD have to be the same. Now the reason for that, I have two radiuses, two radii. You're going from the center to the outside of a circle. Those have to be the same because of the definition of a circle. Now, there's another spot here. This side of the triangle and that side of the triangle are both going from the center of the circle out to the edge of the inner circle. So those have to be the same. So I'm going to write AO is congruent to CO. Now the reason for that, again, definition of a circle, but really we're just looking at the inner circle now. Now these two triangles, if you drew them separately, would look kind of like this. I know these are the same, I know these are the same, and I know that these are the same here. So because we have three sides the same, we're going to say triangle OBA is going from the center to B to A, has to be congruent, and this is the only way you could write the other side if it's OBA, ODC. And the reason for that, SSS. Now, if those triangles are the same, then I know all the angles have to be the same too. So I know that angle AOB, this angle inside here, has to be the same as angle COD, because they're corresponding parts. So that's the reason, corresponding parts of corresponding figures. And we'll end with QED. So there you have it. We have two proofs in our notes. Right here and right here.